Are we live? Okay. Well, welcome, ladies and gentlemen, to the Parkes Observatory's live stream of the lunar occultation observation of the very bright quasar 3C273. Now, 60 years ago, there were a series of 3 lunar occultations of this this bright radio source, which is a very rare event. And so, fortuitously, in the first year of the telescope's operation, there were 3 occultations visible from Parkes. And at the time, Dr. Cyril Hazard, who was at Sydney University at the time, took the opportunity to do these lunar occultation observations to very precisely determine the position of this bright radio source, and which later others were able to obtain spectra and determine that this was an extremely high redshifted object, very, very distant. The discovery of these things, which were later dubbed quasars, revolutionized our understanding of the universe. It increased the size of the universe, the known universe, tenfold. So it was actually one of the, or arguably, one of the most significant scientific discoveries in Australia's history, and indeed with the Parkes telescope. We're very pleased to have with us this evening, or today, Dr. Cyril Hazard. He's present in the UK, and he'll be joining us shortly. We also have Dr. David Jauncey, who'll be making a brief presentation and describing some of the significance of the discovery. Here in the control room, we will be monitoring the quasar. Hopefully, we'll be able to observe the fringes. Unfortunately, it is quite windy here today, so we're hoping that we'll get away with it and be able to observe it, in both the immersion and immersion. We have in the control room with me Dr. John Reynolds, who will be doing the observation. And so, but I think just to start off with, I would like to introduce Dr. David Jauncey to say a few words. So, David.
Thanks very much, John. Okay.
Yeah, I will share the screen with you if you give me a second. Play from the start. And here we go. There we go.
Okay. This is just a quick run through, as John pointed out, the cast at Parkes. It was the early days at Parkes, and those of you who have used it in the past will notice the significant differences between the telescope now and the telescope then. But it was still a perfectly good working telescope. Cyril Hazard was there as the guest observer from Sydney. The telescope was being run by John Bolton and as the director, and also John Shimmons. Cyril was there because he'd been given a talk at radio physics when he was at Sydney University on occultations, and Joe Pawsey and Bolton were well aware of the potential value of occultations in determining precise positions. And so they had, Joe Pawsey himself had actually invited Cyril to come. Now, John, I guess I don't change the slide. I think you do you not?
There you go.
Okay. As John said, there were 3 occultations. Interestingly, the May 15 was a sad one in many ways. It showed the first diffraction fringes. But the fringes came because the telescope was right at the limit, it was stationary, and the whole record simply had the moon coming into the beam. So all that you saw was just the rapid increase in amplitude with a couple of wiggles on the top. And I'm hoping that we'll see some more of these diffraction wiggles, which are a significant part of the occultation itself. And in fact, these wiggles showed that 273 was the first any occultation to show these diffraction spikes, these wiggles. And so the preparations for the next occultation in August, there was a big concentration on these two because now, yes, there were some very nice compact components. So the next occultation they're getting ready for was the 5th of August, and that was to be followed by the 26th. The 5th was at 136 and 400 megahertz, and it had both the immersion and the immersion, if you like, the disappearance and reappearance. And in October, the parks had dual frequency systems, so it was the 410 and 1420 megahertz. And so the build-up was very big. John Bolton had quite a go to make sure there were no problems, but that's a different story. Now, next slide, John, please.
Recording in progress.
Okay, this is the scenario. This is for the occultation. If you like, in the reference frame of the moon itself, the occultation passed almost across the middle, but it came, the initial contact was at one angle and the other contact, in fact, was at quite a different angle. And so you're getting two cuts across the moon. So at 136 megahertz, you can see that the immersion and the, basically, there are just the beautiful diffraction spike wiggles, if you like, on the record itself. And basically it looks just like a single source. Whereas interestingly, at 410 megahertz, this is the immersion that's heading under, and as it heads under, they were tracking the radio source, not tracking the moon. And so as the moon hits 3C273, you can see the diffraction spikes, but also, very interestingly, there is a jump in the middle as the moon goes over, indicating clearly that there were two components there, whereas in the immersion, there was just the one component. They were both lined up together, and you can see the wiggles there. So it's two components, and they're separated by about 45 degrees. You can see, if you like, just the nice little picture up there at the top. So the first occultation clearly revealed a great deal of information. It's telling you that the components are compact, that there are two components at 410 megahertz, whereas basically only one component at 136. So we'll go on to the next slide, which is the next occultation. There was only the reappearance. The point is the moon wanders all over the sky all year, and so these are quite unusual occultations. So there's only, time is increasing, time is going this way. And so you're tracking the source at 410 megahertz. You can see once again the diffraction wiggles, and you can also see, given the angles, etc., that it's separated into two components at 410 megahertz. The really interesting and new thing that happened at 1420 was that where you've got here, you've got the B component, the A component dominating, and there's the B component at 410. At 1420, it's the B component which is suddenly not less than the other, suddenly significantly stronger. And you'll notice there's a minute and there's a minute. The wiggles at 1420, because of the higher frequency, the shorter wavelength, the wiggles are much more rapid. And so it says there are two parts to this source. There's component B, and the spectral index of that, as you can see from here, is roughly 0. It's roughly the same frequency at both 410 at 1420, and up until this time, no other source or source component had been seen with this mode of frequency, because all the surveys are done at the lower frequencies. They're finding all the steep spectrum sources, but the steep spectrum source in this instance now is the A component. And so suddenly we've got a whole new set of types of sources, if you like, inside the occultation, inside 3C273. So the next slide, please, John. With both occultations now, whoops, what's happened? What's happened, John? There we are back again. They Hazard and the people from Her Majesty's occultation people in the UK now have 3 cuts. So you can see here are the 3 cuts that you just saw in the occultation. There are 2 from the first one and 1 from the second. And so what is happening is there's the B component here turns out to be coincident with the bright star, and the A component down here is at the end of this thing sticking out the side. I'll explain the background, the optical measurements. The photo is courtesy of Martin Schmidt, but it shows clearly, after a lot of negotiating, calculations and communications, the radio position now is absolutely coincident with these 2 components. Now, Schmidt initially was worried before he had the final detailed. He had an initial measurement which put the average of the 2 410 positions right here in the middle. And so initially his initial response was, okay, that's a jet, and that's a galaxy, and that may just be a bright star. And so things changed very rapidly when the position was finally put together. The final outcomes were late in January, and at this point, Hazard wrote to Martin Schmidt, pointing out exactly what the positions are. So next slide, please, John. So at this point, we bring in now in one slide, quite a long story. Martin Schmidt was at Caltech. He had taken over the job of the optical identifications, and I have from Martin this lovely photo of the observer's position in the telescope. You climb up there and you climb down here, and you sit there and you fiddle with these tiny little pieces of glass photographic plates. They're only a few inches in size. So Martin wrote afterwards in the Proceedings of the American Philosophical Society describing what had happened. Initially, there was his redshift, and there are the reference spectral lines. So you can read it yourself, but what he thought was the foreground star, he had an image, a spectrum of, but he hadn't looked because he was concerned that it wasn't the actual identification. Once he got the letter from Cyril, he says 6th of February, he got the letter. The letter had been sent right at the end of January. Reasons that I don't remember, tried to construct an energy level diagram. When they didn't come out regularly spaced, I was annoyed. So he compared them with the Balmer lines of hydrogen. So there are the Balmer lines of hydrogen, beta, gamma, and delta down there. Suddenly he took the ratio, and the first ratio of the Balmer line was 1.16. The second was also 1.6. So suddenly the whole position clicked. And so the third one showed the same thing. So it was abundantly clear This was a new object. It was a bright stellar object. It was blue. Look at the blue end of the spectrum. This is on a photographic plate, and the redshift of this thing was 0.16. So suddenly there was a whole new, really a total change in, as John said, in our understanding of the universe. And the last slide, please, John. So 3C273 became very dramatically the first quasar. The optical and radio images coincided with the first radio jet. Both the August and October spectra had showed that it was an inverted spectrum radio source. This was the first of such things ever seen. The position ended up, the quality of it, because you can time those fringes to a fraction of a second of time, gives subarc second radio position and also subarc second radio structure. This is the first time any object had been measured. And the interesting thing, because the occultation, all the background measurements of the moon are made in the optical reference frame, 3C273 became, and in many instances still is the critical component in the frame tie, and it became also the first radiant optical variable source. So clearly it became the first real black hole. And way back in the early 1960s, a few theoretical physicists had discussed the idea of black holes. Suddenly, here we are today, when black holes are the sorts of things that everybody, even our politicians, talk about. So that's a brief background. I hope it's been acceptable to Cyril being there. We've had a long, Milagos, Cyril and I have had a long collaboration for many years, sorting out all the details. And because everybody wrote real letters to one another, it's been possible to trace all of that back. So that's briefly how, through the Parkes occultation observations, not only was just our understanding of radio sources changed dramatically, our understanding of the universe at the same time was changed dramatically. Okay. So that's it, John.
Okay, thank you, David. We're getting very, very close now for the, I'll just, let me see, I'll switch to, yep, I think we've got the right one. So I'll come over here. So I'll now introduce Dr. John Reynolds to explain the setup, because we're very shortly expecting to see the first fringes, provided we're not wind parked. So John, yep, just unmute John. Yep. Yep.
I'm famous for not unmuting in time, so I'm true to form here. So welcome everybody in whatever time zone you're in. Of course, we're all in one time zone, UTC. If only we lived our lives by UTC, things would be a lot simpler. Thanks to everyone in different time zones who've joined, and thanks to people in this time zone who've stayed up till after 1 o'clock. So we're, as John said, trying to recapture the occultation of 3C273 that was done 60 years ago. And although we're recording on some slightly newer instruments, we are still using a chart recorder. So being as old as I look with the grey hair and all, I do actually remember chart recorders. I cut my teeth on chart recorders at Molonglo. We had something called a Rickadenki. This is not a Rickadenki, it's a Siemens, slightly newer, but the principle's the same. So this was the preferred manner of recording data, obviously, back in the 60s, before digital computers really kicked off. Now, as John explained, we're battling the wind here. So in the hours leading up to this event, I think we got windstowed 4 or 5 times, which has kind of hampered our setup. But we're kind of hoping that we've got the levels roughly right, and that at some point in the next 10 minutes, or actually less than that, 4 or 5 minutes, we'll see the interference, the Fresnel interference pattern unfold beautifully on the chart recorder in front of us. I think everything is set up except for the wind, over which we have no control. So fingers crossed on that one. I was thinking about occultations and how I'd never actually observed an occultation. This is my first one. But then I remembered I have actually seen one occultation previously. It was a Neptunian occultation where the planet Neptune occulted the very bright radio source Voyager 2 as it swung behind it in 1989. And I was fortunate enough to be at Tibumbilla at the time. I was allowed in as the tame astronomer and got to see it on a chart recorder. Actually, I set up the chart recorder from memory because no one else there tended to use them much. I might just interrupt myself here to point out that we seem to be getting some action on the chart recorder. What you see, folks able to see it? They are. What you can see in the lead up here is we're sitting on the limb of the moon. Now, this is something we're doing differently to the way Cyril and his collaborators did it 60 years ago. They were unable to track the limb of the moon because of the computing control software problems. We're lucky enough to be able to do it. One of the artifacts of doing that is because you're sitting on the edge of a very bright object, the moon, slight irregularities in the tracking will cause a little bit of hairiness in the baseline, which you can see in the minutes leading up. But overall, it's a better scheme to be tracking the limb of the moon because it removes the big bowl of the moon going through. And I think even a hardened skeptic would be hard put to deny the fact that we're seeing Fresnel fringes now coming through on the chart recorder. Time will tell whether I have set the scale optimally to capture the full information. I may have been a little bit conservative in my settings and wound it down a little bit. So the fringes at the moment are only roughly a centimetre or so on the strip chart. But we do get a second bite of the cherry when the moon comes out, 3C273 comes out from behind the moon in another 25 minutes or so. So any mistakes we've made this time around, we can hope to do better next time around. So this is not quite the same sort of occultation setup as those observed in the 1960s. What we have tonight is a rather glancing occultation where the moon is just grazing through the path of 3C273. In fact, as the quasar approaches the limb of the moon, seen from the moon's perspective, is coming in at a fairly shallow angle of something like 20 degrees, or I think it's even less, which is slowing down the fringes significantly because the distance between the limb of the moon and 3C273 is diluted somewhat by this oblique impact parameter. So we're looking at a timescale of something 30 seconds is one Fresnel zone. So I've got the chart rolling here at about 3 centimeters per minute, which I'm hoping is about right. And well, I think that the speed of the chart's probably good. So we're seeing
underway.
We're seeing some pretty clear fringes here now. I think what we're probably seeing here is the first Fresnel zone just coming through. Obviously, with the immersion, we see the Fresnel zones in backwards in reverse order. So I think we have just undergone occultation at about 1424 UTC, which is pretty much on the money. So congratulations to the theoreticians who worked that out. And counting backwards, I think it's pretty clear. You can see 1, 2, 3, 4, 5, 6, 7, 8, at least 8 of the fringes preceding that last one. So all looking good so far. As I mentioned, we're not just relying on the chart recorder. We do actually have 2 digital backends running. We've got the digital filter bank circa 2008, I think. Thanks to Warwick Wilson and his engineers in Sydney. That's recording at a rate of 4 hertz, 4 samples a second across a 256 megahertz bandwidth, centered on 1.4 gigahertz. I should have pointed out, by the way, that this chart recording you're watching is actually 1.4 gigahertz. It's near the 21 centimeter line of hydrogen, which was the highest of the three frequencies observed in the 1960s, and the easiest one for us to look at. But in addition to the chart recorder and the digital filter bank, we also have our newest backend, which is a GPU cluster called Medusa, which should be collecting data from between 700 megahertz right up to 3 gigahertz at roughly once per second. So we'll have that lovely data to play with after the event. 1525, it seems as though the immersion is now complete. Because of this shallow angle with which the moon is crossing the path of 3C273, I think the quasar is only going 30 seconds at most inside the limb of the moon, but that is enough. I think that's one Fresnel zone, but that's enough to completely suppress the signal pretty much. So what we're seeing now on the chart recorder is just the limb of the moon without any flux from 3C273. So you can see from the chart, 3C273 was occupying about 6 centimeters on the chart. So we might take a little bit of attenuation out on the second pass just to get a bit more signal to noise. And of course, we need to stop the tracking and switch to the second point on the moon shortly, which will be where the immersion takes place, or the exit takes place.
John?
Well, that
David.
was wonderful. Yeah.
I'd like to ask Cyril, what's it feel like to be observing an occultation of 3C273 again in the park's control room?
You'll have to maybe unmute, Cyril, if you could unmute. That's it.
It's not now you can hear me.
Yes, that's good.
Oh, it's not nice to see this going again and going so well. And rather different to the situation that occurred the last time that I was in there watching our occultations. It reminds me of as to why. I think it might be worth to know why I was involved in occultations at all. And the reason is that when I first started off in radio astronomy, which was in 1959, there were a relatively small number of sources that had been observed, radio sources had been observed. Some of them mainly by, I think, people in Australia. I can't remember. John Bolton was one, I know. And there was and Martin Ryle's group at Cambridge, and using interferometers, and they're producing lists of sources with only limited accuracy because they couldn't produce second of arc positions or anything anywhere near that. But two things were obvious, that among the radio sources which were discovered, there were two types. One was concentrated along the galactic plane, which was obviously was associated with objects in the galaxy. But there's a population of sources at high latitudes which seem to be uniformly spread across the sky, and which generally were believed by most people to represent stars in the galaxies, and they became known as radio stars. And so this idea of radio stars, because nobody could find anything there. So they were invisible objects, but they were stars in the galaxy. Now, for some reason or other, the work I was doing myself on with Henry Brown, I came to the conclusion that this was not correct, and that I joined a relatively few people. I think I remember Westerhout and Oort in Holland. I mentioned this before. Is that these sources in the hourglass were not sort of unusual stars in the galaxy, but were in fact extragalactic. And from that point of view, my intention was to try and explore this. And I wrote my thesis on this. I did a detailed analysis and came to the conclusion that there was no doubt that these sources were extragalactic. At that particular time, I then left Jodrell Bank to do my national service and didn't come back again for a couple of years. And was extremely surprised to find out that people still believed, the majority of people still believed that the sources were stars in the galaxy. And my intention then was, in fact, to try and show that this was not the case. And so I started to think about how is it possible to measure sources to second of arc accuracy, which would enable me to pinpoint these objects in the sky. And I thought of many things which required building enormous instruments, which I couldn't do. But one day I was walking back from lunch with John J.G. Davis from Jodrell Bank, and discussing this problem. He said to me, "Have you thought about occultations of the moon?" And I said, "No," but I went straight back to my office and looked at it. And one thing I didn't understand was diffraction and the interference. And within a very short time, I realized that looking at occultations, I would be able to measure to a second of arc or so accuracy. And so I set about thinking. I made with that. I went to see Professor Lovell and told him this and made a proposal that the new telescope, which was then coming online, could be used to do these occultation studies, and that I could do a survey. So I set out to do a survey of the sky, and hoped that I could pick up new sources by just studying the sky drift through the beam. And I was not very long before I finally got one good source that I could understand quite easily, which was 3C212, which I identified and then published in published position. But the optical astronomers took no notice about this. They didn't seem to take any notice of us radio astronomers at the time very much, and so the actual nature of that source was still unknown. But I was convinced it was an extragalactic object, so I wrote this up, and then at this particular time, I was asked to work at the in Australia on the intense in the interferometer at Narrabri, but I was then thought my radio astronomy career was over. However, I gave a lecture on this 212 at the University of Sydney, and Joe Pawsey was there. And after the thing, he asked me, would I carry on my work at Parkes? And that's how I got into this business of occultations. And so then we picked this up again, and then you know what happened after that. 270, but after that we found many other sources by occultation. With Mackie, I was working with at the time, and it became at much higher redshift. But anyhow, that's the way I got into the subject of occultations. Now, of course, it all looks so simple nowadays, but so it's difficult to think back to the time when people did not believe that these things were actually stars in the galaxy. So is there anything else you want me to tell you about these things? It was really my intention in working it was to demonstrate definitely these things were extragalactic, and so the observations on 3C273 indicated my claim at the beginning, and I was quite happy. And then but I was a little bit annoyed when I found out that we were doing all the work, and optical astronomers were getting the credit. The work to get these things was very difficult, but to take a spectrum was very easy. And so I decided, well, I'll get into that business myself, and I'll start and do. Because within a year, I'd identified several of our sources. John Bolton showed me how to do some optical measurements. Remember, I knew nothing at all about optical astronomy, but he showed me how to measure up the position from the sky survey plates, and I started doing the identifications myself in the following year. I published about 12 objects with my collaborators, which got positions and so on, and the whole business of finding these cases then became very simple. So I was very pleased. I know that it's probably not very coherent, but it's a long time ago now. I mean, it's a long time ago, but I thank you, and I think Dave and other people for inviting me to just ramble on about these times from the past. And I hope that it does shed some light on what was going on in those days.
Well, all I can say, Cyril, is I'm very glad that you did.
Yes. Yeah. Thank you for sharing those reminiscences with us, Cyril. We're getting very close actually now, I think, to the point where we'll be seeing the immersion of the source. So I'll just switch back to John Reynolds and see where we are there. There we go, John.
Yeah, thanks, John. And thanks, Cyril, for that wonderful package of insights into the observations 60 years ago. I look at them now with awe and wonder how you managed to get all that information, including the position, out of chart records. It seems so foreign to the way we do it these days in front of computer screens, even to me, and I'm used to chart recorders, I guess. But it was a wonderful piece of analysis. And I had to bone up on lunar occultations this week just to refresh my memory, and Thompson, Moran, and Svensson have got a good little section on it. But you're cited, obviously, as the author of some key papers on lunar occultations, but they don't actually mention 3C273, which I think is a bit of a shame, because it was surely the most famous lunar occultation of all time. But anyway, I digress slightly. So as John mentioned, we're something like 6 minutes away from the immersion, or the exit from behind the moon, and guided by the amplitude of the fringes we saw the first time round, I have been so bold as to increase the gain by 2 dB. You might wonder why I didn't go for 3 dB, but I'm conservative by nature. So we've gone for a 2 dB increase in gain, and I've gone to school on the 0 level, or the level on the moon, and shifted the pens down to the low end, as you can see. So hopefully we'll get something similar on the way out, but a little bit more amplitude. I mentioned that I was lucky enough to be in the control room at Tidbinbilla when Voyager 2 arrived at Neptune, and was able to see the Fresnel pattern as the spacecraft went behind Neptune. I think there was something like a 40-minute occultation where no signal was received from the spacecraft, and there was a sense of anxiety and apprehension in the control room because people had their fingers crossed, everything crossed, that the spacecraft would still be intact when it came around from the other side of Neptune. I think we can safely assume that 3C273 is not in any danger, and it will emerge. So I'm not particularly concerned. The only anxiety I've got is whether the wind is going to park us, but fingers crossed, we've been lucky so far. Only the wind
It'll
can
ride
stop us.
down.
So we're now about 4 minutes out. So if history repeats itself, we should start to
Let's
see some
start seeing
fringes
them.
in the next minute or so. And the reverse pattern in time should unfold. So I've got the experts on the line here. At 21 centimeters, I'm assuming that the compact component close to the nucleus of the host galaxy is dominant, and we're not going to see too much of the jet, and get something like a fairly straightforward Fresnel interference pattern without the two sources beating with each other, as was the on top of each other, as was the case at the lower frequencies that Cyril and his collaborators were working with. But that, to me, is part of the magic of the original observations, that we were not only, Cyril was not only using it to get the position, but to derive the structure of the source. That's just an amazing idea in retrospect. And it was something that revolutionized astronomy, really. It exposed, to me, it links the optical and the radio worlds together in the sense that optical astronomers were forced to confront the idea that something that looked like a star was in fact a distant galaxy pumping out enormous amounts of energy. Truly a transformational moment. So we're now down to 3 minutes. So we should be starting to see something.
Starting to see it.
In terms of show and tell, looking at wiggly lines on a chart recorder possibly doesn't cut it with the younger generation. But I'm just amped up, I can tell you. I'm counting the seconds until we start seeing something happening again.
Yep, just starting.
In fact, the occultation of Voyager 2 by Neptune was made more interesting by the fact that you could see the different layers of the atmosphere having an effect on the Fresnel pattern as well, which someone helpfully pointed out at the time. So there was complexity in that event as well. It wasn't just a simple knife edge diffraction on a point source. They're about 3 minutes away. So I'm trying to kid myself. We've just seen the first fringe, but I think I'm getting a bit overexcited. But just looking back at the fringes from the immersion, it reminds me, Dave, of one of your favorite sayings that goes along the lines of bad data is worse than no data at all, but good data is like a cool summer breeze. So I think that's a demonstration of that. Now I am starting to get a little panicky. Have I actually got the right set of coordinates in? I believe I do. That's all right, just have to be patient. $12.29.05. Yeah, okay. Well, we should be starting to see something. Of course, yes, I'm getting confused here. We don't see fringes on the immersion until the point of contact's reached. So I'm making myself anxious for no good reason.
The level's going up though, John. The overall level.
It is. Yes, I think we might be starting to see it now, Dave. I have faith.
Is that what you expect for a grazing incidence occultation, Cyril?
Pardon?
Is that the sort of thing? Did the grazing incidence occultation
There it goes.
memories?
Yeah, I think we're on the home straight here.
There it goes. You know, it starting to give me memories of the time when I was sitting, and we were all sitting around watching for the first really good occultation, the second occultation of 3C273, and how we saw the excitement as the source began to drop, and the exclamation from Peter Sawyer, who was there at the time, "Look, it's double." And that was the first time I realized it was a double source. And the great excitement there, which was to get such good observations. Oh, there's good. This is good.
Is it true, Cyril, that you had 2 chart recorders running in parallel?
I don't know. I think that there was, but there's a few myths about what went on there, of course, about why I traveled back. I think with one chart, and John Bolton had another one in case anything happened. Actually, what actually happened, as far as I know, is that after the occultation, I got my copy of the chart and went back to Sydney because I had my own. It was a bit difficult for me in many ways because I had my own work to do. I was sort of lecturing at Sydney, working at Narrabri. I mean, and I was always hopping around from one part of Australia to another, and we were living at Narrabri for much of the time. And when this was going on, and to get to Parks, I had to make a long drive down what were really dirt roads most of the way in those days.
One of my favorite myths, Cyril, was that you carried the results back to Sydney in a briefcase handcuffed to your wrist.
Oh, yes. I don't know who invented that one.
It's developed a life of its own, though, now.
I didn't really know that. I think I possibly had it, but no, that was no, it was all a bit more prosaic than that, actually. I took the chart thing and got on a plane. I think I got on a plane and back to Sydney. And then of course, after that we did do many occultations. The what point was, by this I couldn't be there all the time, or that I was working on the analysis of things. But Brian Mackey, who was working with me at the time, he was would get everything set up, and he was a big help. And then John Simmons as well, to get the make sure everything was all right. Oh, this is a good one. Oh, that's pretty nice. Oh, it looks just like one of the old ones.
I think we are still
So
seeing
what frequency is this?
1.4 gigahertz, 21 centimeters. Or L band, take your pick.
L band, yeah. So this is now the ratios look much the same, don't they? At the low frequencies, at the 100, whatever it was, we did high one.
Well, yeah, a spectacular record.
We do seem to have a little bit more fluctuation in the background this time around. This general rise here, I don't think we saw on the way in.
Yep.
Possibly. Oh, no, it's not too dissimilar. Yeah, okay. So it is a slightly more complex situation, I guess, than a simple knife edge diffraction. You've got possible source structure. You've got the finite size of the telescope beam, which shouldn't come into play, but perhaps is coming into play more than I thought. Sorry, I'm getting a message from my production manager here. I'm not quite sure what it is.
I'm just Ron has posted a message on the chat, Zoom, that we are seeing the second component, the jet emerging.
Ah, right. Yes, of course.
It's considerably smaller in angular size.
Yeah, so there is something like a, let's see, 30 or 40 degree difference in the angle between the immersion and the immersion. So it is not terribly surprising you get a different cut through the source. So that could well explain it.
Yeah, Ron says that the position angle is different in and out. So yeah.
Thank you, Ron. It's always good to have Ron in the background picking up these things.
Well,
okay, well, I think that's probably all the actions as far as the occultation itself is concerned. So I think we can declare victory on that one. We defeated the wind, and physics is proved again to be true. And the humble chart recorder once again comes into its own. Something I meant to add is that when John and I were doing a test a couple of weeks ago, we were tracking the limb of the moon and seeing some funny sawtooth tracking, which perplexed us for some time until we worked out what it was. In fact, it was a rather bizarre problem because every time the safety timer, like the vigilance alarm that we have, which resets itself every 15 minutes, every time that went off, it would cause the telescope to miss track, which doesn't sound very likely. But there was a subtle, bizarre link in the software between the two. And it struck me that we would never have found that if we hadn't been using the chart recorder. So once again, a victory for the chart recorder. So I've been motivated now to give this chart recorder a bit of an overhaul because it's been sitting around basically for 10 years since I was officer in charge here. It hasn't had a lot of use since, but I think it probably...
You better padlock it to your arm and take it away again.
Well, actually, the hardest part was finding ink, the pens and that had ink in there that we could use. So that was the hardest part, you know. So yeah.
Yeah, I think I figured out how to refresh the pens that we do have without, and hopefully without getting too much ink on the fingers. So I think there's a few years left in it yet.
I'll look after it.
Yeah. Okay. Well, I think we're pretty much done then. Hey, are there any questions, Miller? Did you have anything you wanted to add?
Yes, just one very simple comment to Cyril and Fiona. Remind both of them of the incredible hospitality that the Hazard family provided to the Gosses twice during 2 visits we had to Cambridge. Once we stayed with you, and my very small contribution at the time was to work on the organization of Cyril's archive, and I think Jean and Fiona were pretty shocked on a Sunday afternoon when the whole living room was full of paper, but they were in nice, neat stacks, and we found lots of incredible jewels.
Yes, well, that was really good for me, sorting out those old records and what was actually going on in some of the things which in the background, which we know about. But you unraveled a lot of those things which I did not know had been going on. So,
and I was so thrilled, Cyril, I saw Fiona very slightly in one of the images, and please send her our best greetings to her.
Hello.
Fiona,
Oh, hang on.
we have fond memories of your hospitality, Fiona.
Do that again,
Good,
Fiona. There you go.
I'll drop out now.
Well, we all hope that it's not too long before we see you both again.
Yeah.
Thank you. It was a great experience for Olivia and myself, Cyril.
yeah, that's nice to hear. And I mean, I wish that, you know, that I'd been able to come back to Australia sometime again, see people, but too late now.
Yeah. Well, folks, I think we're coming close to the end. I just wanted to thank a few people. Number one, John Reynolds, for setting everything up here, and to be here and to actually see this happen is absolutely amazing. To David, to Ron, David Harold, who's not with us, but I'm sure he's watching on YouTube, and to you, especially Cyril, for joining us this evening. These events are very rare to be visible from parks. These lunar occultations of 3C273. You were fortunate in 1962 to have 3 in the 1 year, within the first year of the telescope's commissioning. And in fact, it's so rare that the next one, visible from parks, is on the 7th of January, 2037, 15 years from now. So earlier this evening, while we were setting up and the telescope was being windstowed constantly, I thought, oh God, we got to wait. We have to wait 15 years for the next one. So
I don't think I'll be around to see that.
Well, I'm glad you were able to see this one, and you were able to join us for this. The identification and discovery of quasars was definitely one of the great discoveries of astronomy, not just radio astronomy, but in astronomy. And your contribution to that was immense. And
well, I just consider myself fortunate, you know, in my life to being able to get the access to the equipment and so on, which is available. And
well,
at parks, and
we have a fantastic bit of equipment overhead, and I'm just I'm just totally stoked with the fact that we were able to see it tonight.
Yeah. What was that, Cyril?
Say that again, Cyril. We missed that.
Just saying, it's a lot more complicated what you have there now than was around when I was watching the occultations there. We were sitting beside the control desk watching people gathered around. I can't remember, quite a big crowd of people watching. And
oh, we don't have that problem tonight, that's for sure. It's just, not in the control room anyway. Outside there's plenty, but no, it's been absolutely fantastic. And as I said, with minutes to go, we were wind parked and they're constantly going up and down. And the fact that we were able to see both the immersion and the immersion is just absolutely fantastic. Well worth staying up for this. So big thank you to everyone. John, did you want to say a few concluding remarks too?
Just have to find my unmute button. Well, I'm pleased to have played a small part in presenting this. It's, as John's saying, it's a pretty rare event and an historic one. So a reporter asked me the other day, what new science do you expect to get out of this? And I said, well, I'm not sure that there's, you never know, we might get some new science out of it, but I think the purpose of it was really just to honor the events of 60 years ago and maybe share some of the excitement, Cyril, that you and those in the control room at that time felt.
I also had excitement getting to parks many times, driving down from Narrabri. In fact, in one case I remember I was crossing some mountains and I got to the peak and we were going down and the accelerator jammed. Took me a long time to understand what had happened, and the car was just accelerating up to 70 miles an hour going down. I finally realized I could go into neutral and we coasted down straight to the town below. Then I stopped and found out that the chain operating had broken. I hunted around the road till I found a piece of wire, which I then patched in and patched up and then carried on. That was one of the adventures that I had there. Another time I was coming back from parks, I took the wrong turning and suddenly realized that all the signs were pointing to Sydney. And I was a bit desperate by this time because I only had a couple of pounds in my pocket and I was running out of fuel. And but I took a shortcut to the Pilliga Stub and got lost in there and thought I was never going to get back.
Folks, we may be cut off shortly. I'm sorry, Cyril. I didn't mean to disturb. Just that we're coming to the end of the Zoom. I don't want to have. I'm not sure how it'll work, whether it'll cut off or not. But I do apologise. But we're again, just wanted to thank you very much, Cyril, to Dave Jauncey, Ron Eckers, David Herold, and to this great man here, John, for making it all happen.
Well,
thank you very much, everyone, for joining us tonight.
Well, thanks to you. Thanks. I thank you as well.
And we hope to get beautiful copies of the chart recorder.
Oh, that's going into the vault. So we'll make sure. And I just can't believe the scale. In fact, let me see if I can just, to finish off. Let me see. Oh, hang on. Let me just stop that for a moment. I just want to make sure I have the frog there. Yeah, there we go.
Oh.
And where did it go? There we go. And there you go. You can see the dish tracking the lunar limb. You can see the wind beautifully just came down for us just as we started.
Keep a copy of that record too, John.
Oh yeah, I definitely will. So it's been wonderful. So let me come back here. Oh, let me stop sharing that. So once again, thank you very much, everyone, for joining us. It's been a fantastic night. I'm absolutely stoked. I probably won't be able to sleep after this for several hours. So, but I wish you all well. And always remember, for me anyway, radio astronomy in general is a lot of fun. I love doing these things. And so, and to be able to recreate those famous observations tonight has been absolutely fantastic. So thank you all. Thank you for joining us. And we wish you all well. Thank you.
Thank you too, guys, for making all of it.
Bye.